Hello, and welcome back to Dozzy's Television Workshop. In the last episode, we had the line output transformer removed from the Philips 17TG100U, and we're going to pick up on that now. Just a quick refresh. We found that this winding here, which is the heater winding for our EHT rectifier, which is also offset by the EHT, so between sort of 14 and 16,000 volts DC on this winding as well. We found out there's a little hole around the back here, and it was arcing to our transformer primary. Not a good situation. So that leaves us with two problems really. One, obviously this winding has failed, and the second problem is it might have damaged the primary because obviously that arc from the high voltage section was going somewhere, and it was going through the insulation, the primary, and damaging that. Let's hope that's going to be all right, or that's going to be quite a job. But first things first, we need to discuss what we're going to do. And last time I said possibly the easiest thing is to get some new high voltage wire and simply rewind this winding. It's only a few turns. There's 1, 2, 3 turns there to give 6.3 volts for the filaments, for the heaters on our EHT rectifier. There's also another plan. Cast your mind back to when I did the Pi 169 chassis. And it was sort of a game of two halves there, as they say, because originally the original line output transformer, it failed somewhere, and that was the end of that. We got lucky. Somebody donated another line output transformer, but it had an inbuilt rectifier, so it means we could do away with the thermionic rectifier. Good plan. I'm going to have a go at that particular course of action. This EHT overwinding here is in good condition, we think, so there's no reason why that can't stay. This, obviously, it's not going to have a valve to connect to anymore. So what are we going to use? Well, inspired by Mega Wayne D on YouTube, and he's also on the VRAT forum and on Facebook, he's used these things. Now, this is an HVM12. Oh, can we do it? Can we do it? Can we get in focus? Yeah, look at that. It's an HVM12 microwave oven diode. Here's the data sheet for our HVM, what's this, 5 through HVM16. Oh, we got an HVM12, so it's in there somewhere. Features: low loss, tick, low leakage, tick, isolated case, brilliant. 50 amps peak overload. If we ever draw 2 milliamps out of this, that'll be something else. Mounting position, any, tick, good. Low forward voltage drop, tick, good. Mechanical data, the device has UL flammability classification, excellent. That probably means when it catches fire, it only smells a bit nasty. There we are. Right, so we've got an HVM12. Maximum recurrent peak reverse voltage, 12 kilovolts, not enough. Maximum RMS voltage, 8.4 kilovolts, not enough. Maximum DC blocking voltage, 12 kilovolts, not enough. What we're going to end up doing is, if you see these kind of assembled rectifier, and they are literally just a stack of diodes in there. So we're just going to stack 2 lots together. That'll give us 24 kilovolts there, 16.8 there, which is more than the sort of 14 or 16 we're probably going to see, and that's going to be fine. Here's the doozy, and here's why it shouldn't work. Maximum ratings and electrical characteristics. 25 degree, ambient, blah, 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 blah. Single phase, half wave, 50 hertz. 50 hertz. 50 hertz resistive or inductive load. Okay. So, yeah, 60 hertz. So our 405 line System A television set, the line rate is 10,125 hertz. But as we saw on Wayne's video, Wayne was running his set at 625 lines, which has a line frequency of 15.625 kilohertz. So it would seem these diodes are certainly a lot better than their 60 hertz rating, and they were cheap. So yeah, let's assemble this, and hopefully we have as much success as Wayne did. So I'll link to Wayne's video down below in the description. But he's had great luck with these, and he's running on 625 lines, so it should be a breeze on our 405. So what I'm going to do, I'm going to remove this valve holder. It's going to be involved drilling out these rivets here, I think, possibly from underneath. I'm going to cut it off first so I can safely remove the transformer. Why am I talking about it? Let's just do it. So I'm just going to cut through the faulty winding. That will allow me at the moment to lift the transformer clear. Oh no, it won't. We've got one caught up. Oh, it has been desoldered. Okay, so I'm just going to put that safely to one side for a moment. And we need to get this valve rectifier holder out. I'm going to reuse this anode cap lead because despite its age, it's in really good nick. So let's drill these rivets out. I need a drill and a drill bit. I suspect they're only aluminium. So there we are. In fact, use that one. There we go. Right. Excellent. I'll give that a little clean up in a second. So, I'll just pop the base off this so we can see inside. It's only some windings. I mean, if this fails, we might have to go back to it. Oh yeah, there was another benefit I was going to mention about having this. Because our primary has been a little bit warm in the past, obviously now it doesn't have to supply the filament, the heater voltage for the rectifier anymore. There's that mark. Look, see that really clearly now. So this is good news. So there is less of a load on the primary. Not by much, I'll give you that. Not by much at all. Only probably just over half a watt into the heaters. I'll calculate that in a minute. So yeah, probably not a lot, but it's another win, isn't it? It's another gain. So let's just snip this off here. Interesting, actually. This blue high voltage wiring, it's breaking down all over the place. Look, it's gone horrible. Yeah, it's gone like sticky. So it's a case of insulation breakdown. The polymers we've used in days gone by are all no longer any good. And there's our winding removed. No more. In fact, there we go. Look at that inside there. Let's can we focus on that? And this has all gone really sticky and nasty. But you can see it's just, and that's where it let go just there, burning away. Oh yeah, you can see. Oh, let me get it in. Yeah, there we go. See just there. Horrible. Hopefully it's survived. Right. I'm going to need this anode cap, so I'm going to snip that there. There it is. I'm going to have a little clean up, I think, because, well, that's a bit dusty and horrible. So that's now redundant. Let's zoom up out of it so you can see what I'm doing. Right. We are going to want two of these in series. Both pointing the same way. So what we're going to do is have a little bit of power on. Cut. Let's just leave a few mil there. And a few mil there. And let's join these two together nicely. We can do a bit better than that. that looks good. All right. Let's just a little zoom in. Let's get the words nicely showing. There we are. Right, we just want to solder that up. In fact, I'm just going to tin each end to start with. And get hold of the universal vice. So it's cold in the workshop, it's lost all its pliability. There we go, one blob there, one blob there, one of those in there, and on one of those there. Move it all around till we're happy with it. That's it. Now, as we said about in the Pi video we did, the trick is with high voltage connections is to try and, you don't want to leave any sharp edges on there because that encourages corona discharge, and we want to sort of avoid that if it's all possible. Right, there we go. Let's just have a little look at that. Yeah, sort of a nice blob in the middle there. Okay, now the transformer end of things. So what we could do, we need to sort of mount this where it's going to be happy and not sort of arc over everywhere. So what I'm going to do is I'm going to actually detach here. Shall I? Yes, I think I will. I'm just going to detach the EY top cap connector, and I'm going to solder our diode straight in there. And then what I'm going to do then is get some silicon tube, as we had last time when I did the Pi. See if this is going to fit. So the diode's going to go like that. Silicon tube pushed down over it, and we'll solder our anode cap in on that end. Right, I'm happy with that, I think. So I'm just going to lose this spade connector off the end, and I'm going to put a little loop on there so I've got some surface area. A little foot on the end. So, not happy with that. Straighten it out a bit. There. That go on somewhere like that. So let me tin the end again. It's zooming out. There we go. Let's just get this all nicely tinned and fluxed up ready. Wayne, on his tripler construction, he used candle wax as an insulator. Just ordinary candle wax. Worked brilliantly. Yeah. Right, is that... I'm not so sure that's going to be strong enough. Now you see it's wobbling about the place, isn't it? What to do? Ah, that's firmed up no end. Okay, let's see how we get on. Take that end off. Tin that end up. So this is our DC end of things. And then we're going to get a bit of silicon tube. And I'm going to cut that to be slightly longer than everything. There we go. I'm going to slide that onto the anode cap lead. Let's strip a little bit of this back. Again, nice blobby connection. Try not to leave any sharp edges on it. And what I'm going to do is hook that bit of solder out of the way for a start. I'm just going to push that tube over our diodes to offer us some further insulation. And if the mod's successful, I'll do with it what I did with a pie and fill the remainder of the silicon tube with silicon rubber. Oh, this is tight. This is really tight. I think we may need a shade of lubrication in there. What have we got? A little bit of sleeve oil would be nice, but haven't got any of that here. There we go, some mineral there. No, my luck, this will probably rot the silicon. It's not going to go on without it, so. That's better. There we go. It's coming. There we have it. That's good. So now all that remains to happen is for the line output transformer to go back onto its bracket and solder all these wretched pesky tags back up. Thankfully I marked them all carefully as I took them off, but yeah, it's going to be fun and games. Right, let us sit that where it wants to be sat. There. Okay. I'm very nervous about this, wrenching this button off this winding here. That would be disastrous. Do you know what? I'm just going to remove it just until we get the thing back in the set. Yeah. I'm just a little bit worried we're going to do some damage. And if that happens, we'll be into doing the tripler trick here, weighing ourselves. Right, okay, yeah. So let's install all these connections back in. Fabulous. I'm thinking that's done. Like I said, I've taken that off because just not confident enough to leave that possibly bending around in the set and snapping off the connection to the HT winding. That really would be ruin my day. Let's not have that. Let's get it back in the set. Right, well, the set's back on the bench, and just in moving it beforehand, when I closed the chassis when I took it off the bench, I found this tucked inside the back, right in the corner. And it is Bernard Smith Radio Limited of 101 High Street, Barnstable. Telephone Barnstable 3314. Bernard Smith Radio, a Murphy dealer. What were you doing looking after a Philips set? But there we are. If Bernard Smith, you're still with us, do take a bow. Yes, your set's in safe hands. There's some details on the back of the card. I'll put some high-res pictures of this up. I can't read what the top one is because it's in television engineers stroke doctor's handwriting. The bottom one said Says open circuit of a dropper resistor replaced and a PCL82 frame. So that's probably one of those polo sections we see in there, and a PCL82 frame output valve. And that's dated the 21st of December 1967. Well done, Bernard Smith. You saved Christmas. The second one, it sets something biased resistor replacement, something control series resistor replaced. Oh, it's a bit blurry. I'll stick up some pictures of that anyway. 19th of November 1970. Well done, Bernard Smith. Good work. Right. That aside, I love stuff like that. It's great. It's a real slice of history. That aside, we have now got to get our rather naked transformer back into the chassis of the Philips set, plugged back in and switched on and see what happens. Right, let's get on it. Okay, we'll just attach the line output valve top cap and the boost rectifier's top cap once again. Now we've got to make that anode connection. I'm just going to snip that off. It's in the way. Those aren't snips. So here's my anode cap. And I do really want it coming out sort of this way a bit. But it does sort of loop down over there, doesn't it? Through that and then onto the final anode. Just for test purposes, I guess that will do. Right. Maybe if we do put it on this way, we can sort of secure it. No, I don't like that idea at all. I've gone right off it. Right, as we were. No, that's really putting some pressure on it there. I think we may go back to the idea that Philips originally had with the wire on the button. That's just too problematic. So I'm going to unsolder this anode, this top cap. Yeah. And we'll use this bit of wire just to attach it on, at least temporarily, just so we can see if it operates. And if it does, well, we can tidy it up afterwards. Okay. Right, so let's put our EHT cap back on. Turn the set round and power it up, see what we get. Hopefully no arcing. We've got the set round the other way, so you can see the picture tube. I've got the handy cam here. I'm going to keep a careful eye on any EHT spillovers or arcing again from our line output transformer. So, without further ado, that's power applied. The red light is on. Let's wait for some valves to warm. Whoa, and there we go. That, ladies and gentlemen, is a pretty good result. Let's have a look around the back for any unpleasantness. Nope, that appears to be good. Well, obviously we've got a way to go. We've got flyback lines and not enough width. I'll tell you what, we're only at 200 volts. Let's just go full voltage. Wow, just gets brighter and brighter. That's fantastic news. No signs of any arcing whatsoever. Do you know what? I think it might be time to try and get a signal up it. Let's do that. Right. This is an almost very nearly complete Hedgehog standards converter. It's designed by a guy called Frank. Great piece of kit. You could build one of these for about 70 quid all in. This is a Mark 1. There's now a Mark 2, and I think there's a Super P, but it's called PSG version that's almost done anything to anything standards converter. A really clever piece of kit, and thanks to Frank for open sourcing this and making it available to the community. It's a brilliant bit of kit. I'll link Frank's website down below. Yeah, anyway, we've got this connected up to the set. Let's put some power on and wait for those valves to warm. So there we go. Frank's standards converter is currently just outputting the Hedgehog standards converter test pattern. And look at that. I have a confession to make. I had to make some adjustments. However, the amazing thing is, the only thing I've adjusted that wasn't available to the consumer, i.e. one of the knobs on the back that normally sticks through the back so the customer can adjust them. The only one of those I didn't, that wouldn't have been adjustable by the customer, was the line linearity control, which I did have to adjust. All the other adjustments I made: brightness, contrast, vertical hold, a little tweak to the line hold. Oh no, I did have to adjust the width as well. On minimum width, I remember in the previous episode I set the width plug to minimum because it was previously on maximum. We don't need maximum at all because we're just in about the right place. Not quite maybe, but if that was an ordinary picture you wouldn't notice. And there it is. It's working quite well. It's not the sharpest thing in the world. I think maybe some adjustment of the focus might be in order, but I reckon that's a pretty stable picture. I'd be happy to watch that. Now let's go and see if we can find a video source and watch some real pictures without getting a copyright hit. Yeah. There you have it. Very few repairs needed really for this 60-year-old TV set. A little bit of a bodge to the line stage. We've still got some jobs to do, of course. We've got to put those capacitors and restuff the can, mount that back in neatly. There's that capacitor across the audio transformer. We need to replace that. But yeah, very few repairs really. I've got to pop that high voltage diode. There is a slight whiff of ozone coming out of the set. Very, very slight. I can't see any arcing. It's just a tiny little bit from somewhere. So a bit of silicone rubber will seal that up nicely. And yeah, there we are. Thanks to Mega Wayne D for the inspiration to try those microwave oven diodes, and yeah, looks good. So thanks for that. Like, subscribe and click the bell on his channel as well as this one, and come back soon and we'll get this set finished off and tidied up. Thanks for watching. See you soon. Goodbye. U. And I was gonna, yes, I'm gonna do this again because it's a right pig's ear. Yes, super. Thanks for watching. Thanks for, let's just stop this and do it one more time, please. Thank you. I'm just going to move this camera around a shade. That's better. And wait till it stops wobbling itself about. That'll do. Am I looking good on it? Oh, damn, I look good. Let's wipe that splodge off the screen. That'll help. Cheers now. That's just the last bit. Just ain't quite right. Right, last go at it. Well, there you have it. Damn reasonable pictures, I think, for a 60-year-old set. Don't like that word. Let's do it again. TV set. Yeah. Thanks a lot for watching. No, it's too soon to say that.